Key concept 7, target B.
Yeah, YouTube channel is at Math Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors.
Number 7 from the study guide. Line S is parallel to line T. Find the measure of angle 1. The diagram is not drawn to scale. Right? Now, they want us to find measure 1. Okay. So right here, question mark, that lets me know that that's what they want from me. All right. Now, they do give us some information. They tell us that the lines are parallel, so line S and line T are parallel. They also give me this one angle right here, 110. Okay. Now, the simplest way to do this is to think about angles that are supplementary. So when two angles are supplementary, that means that they add up to 180. Okay. Right here, line S also forms a straight angle, which measures 180. So angle 2 plus 110 should give you 180 degrees. So in order to find angle 2, the one right next to it, I just got to do 180 minus 110, which is going to go ahead and give me 70. So I know that angle 2 must be 70 degrees. Okay. Now keep in mind, any two angles next to each other, any two angles that are consecutive, should add up to 180 degrees. So if angle 2 is 70, 8 must be 110, which means 5 must be 70. Okay. And remember, with a picture like this, you're not going to have two angles that measure the same next to each other because they need to add up to 180. The only time that would happen is if they were both 90. In this case, we have 70 and 110, so they're going to alternate. Right? We're going to take this top image, the 2, 110, 5, 8. You slide it down, and it's the same thing here. So 4 is going to be 110, 6 will be 70, 3 will be 110, and 1 will be 70. Keep in mind here, the only one that they wanted was angle 1. So you can go ahead and tell me that the measure of angle 1 is 70 degrees. Number 8. If Treat Avenue is parallel to Van Avenue and Treat Avenue is perpendicular to No Street, then what else must be true? All right. Now, let's start with the first piece of information. Treat Avenue is parallel to Van Avenue. Okay, so I'm going to call Treat Avenue TA for short. It's parallel. This is the symbol for parallel. Two parallel vertical lines to Van Avenue. So I'll call that VA for short. So let's mark up the picture for that too. Here's Treat Avenue, and it's parallel to Van Avenue. Okay. Remember, the way I can mark that on a diagram is by drawing this arrow to show that those two lines are parallel. Okay. Next piece of information. Treat Avenue is perpendicular to No Street. Okay. So Treat Avenue, again, TA for short, is perpendicular to No Street, NS for No Street, and perpendicular looks like an upside down T. All right, so here's Treat Avenue again, but now we're being told that's perpendicular to No Street, which means that not only do they intersect, but they form right angles at the point of intersection. Okay. Then they're asking us what else must be true. Notice they don't tell us anything about Grant Road, Mission Street, or Clay Street. So whatever we say needs to be about the three streets given to us. Now, if you look at it, the only relationship that they haven't given to us yet is how is Van Avenue related to No Street. Okay, so whatever I say, it has to be about Van Avenue and No Street. Okay. Now, if you look at the picture, here's No, here's Van. We're obviously not going to make an argument that they are parallel because they obviously do intersect, which leads us to believe that they might be perpendicular. Now, the justification for that. If you think about the previous example we did, where one of the angles was 70, the other one was 110, because they needed to add up to 180. I told you that the two angles would always switch off, that they would never be the same next to each other. However, the only time where they are the same when they're next to each other is if they're all 90. So if this intersection is 90 degrees, this one over here has to be 90 degrees as well, so that the angles next to each other remain supplementary. So sure enough, Van Avenue is going to be perpendicular to No Street. Number 9, write the missing reasons for the proof listed below. In the figure below, EF intersects AB and CD at points H and K respectively. All right, so let's see what that's telling us. EF is a line. Notice that there's a line on top of it with arrows in both directions. So EF, they're talking about this line right here. It intersects AB. Okay, so line AB is right here at point H. Absolutely. And it intersects the line CD. Here's CD at point K. Sure enough, that's true. So that first sentence is just telling us what we can visually see. Now we need to go ahead and fill in the proof. You should always start a proof with what's given. Okay. So angle EHA is congruent to HKC. Should be the very first statement we make, and the reason we know that is because it was given to us. Okay. So reason number one will be given. The first statement and the first reason for any proof should always be the simplest ones to complete. Okay. Then we're told that angle BHK is congruent to EHA. Okay. Now this makes sense because keep in mind what we're trying to prove is that HKC is congruent to BHK. So it makes sense that we're going to want to say something about both of those angles. Notice that in the first statement, we make a statement about HKC. So then it makes sense that we're going to want to say something about BHK in our next statement. And they're telling us that they're congruent to each other. So let's trace them out in the graph to figure out why. Looking at BHK, start with B, go to H, then go to K. That's this angle right here. They're telling us that it's congruent to EHA. So here's E, H, A. The one in the middle is H. So they're telling us that these two angles are congruent. Notice that as I trace them, I formed the letter X. When two lines intersect and they form that X, angles that are opposite to each other are known as vertical angles. So those two are congruent to each other because they're vertical angles. Right? Make sure you write down vertical angles and you don't just say vertical, because many things can be vertical. So you need to tell me specifically that what we're looking at is vertical angles. Now, the last thing we're trying to show, or we're trying to prove here, is that HKC is congruent to BHK. Now, the statement number 3, that where they got that from is because whatever you're trying to prove should always be the last statement that you make. All right, so we want to figure out why that's true. Now, look at the angles they give us here. So here's EHA. Okay, I'll call that angle A for short. Okay, we're saying that it's congruent to HKC. Okay, that's a different angle, so I'll call that angle B. In the second statement, we go ahead and we use a different angle, BHK. So I'm going to call that angle C. We're saying that it's congruent to angle EHA. We already mentioned angle EHA. I call that A for short. Okay. Notice that B is congruent to A, and that C is also congruent to A. So if B and C are both congruent to A, it makes sense that they must be congruent to each other, which is exactly what we say in the last statement here. So HKC, remember that was B from before. It's congruent to BHK. BHK is angle C from before. So again, if both B and angle C are congruent to angle A, they must be congruent to each other by transitive property. Okay. Remember, transitive property basically says that if two things are both equal to a third, then they must be congruent to each other. Another example would be saying something like, Mr. A has the same shoe size as John. Mary has the same shoe size as Mr. A. If both John and Mary have the same shoe size as Mr. A, they must have the same shoe size to each other based on transitive property. Number 10, fill in the missing statement and reasons in the following proof. Okay, so we always want to start a proof with what's given. Only piece of information given to us is that line AB, which is this one right here, is parallel to line CD, which means that they'll never intersect. So we're going to go ahead and put that down as our first statement. And we know this is true because it was given to us. Okay, you should always start a proof with the first statement that was given to you, and your reason should be because it was given. Okay, that's how we know it to be true. Now, we can't really mark up the picture with that piece of information because they're parallel. The only thing we could do is maybe draw this arrow on it, to show me that those two lines are parallel. All right, now we want to prove that angle 1 and angle 7 are supplementary, which means that they add up to 180. So it only makes sense that I want to say something about angle 1 and angle 7. In statement number 2, I say something about angle 1. I say that it's congruent to angle 4. So here's angle 1. I'm saying that's congruent to angle 4. If we look at it, they form the x. They're opposite to each other. So they're formed by two lines that intersect each other. They form the x. They're opposite to each other. They are vertical angles. So that's why reason number 2 was vertical angles. Now, we're told that angle 4 and 6 are supplementary. So notice 4 and 6 are right here and right here. Before, we would color this and would call this the interior. Okay? Notice that 4 and 6 are both in the interior, and they're both on the right side of that middle line of the transversal. So because they're both on the same side and on the interior, those two are going to be supplementary by what we would call same side interior angles. So same side interior angles. Okay? Do not just put same side interior because, again, when I say same side interior, I could be referring to shapes or sides. I need to be specific and say that they are angles. All right? Now, statement number 4 is empty. However, I told you before, I wanted to prove that 1 and 7 were supplementary. Okay? So, we already said something about angle 1 in statement number 2. Makes sense that we're going to want to say something about angle 7 in statement number 4. And the reason will be similar, so we got to figure out what angle it's congruent to, and we're going to be looking at the same reason as number 2, which was vertical angles. Okay, so let's look at the picture. Here's angle 7. Opposite to it that would form an X is angle 6. So we'll say that angle 7 is congruent to angle 6 because they're vertical angles. Now, the last proof is our last statement. So 1 and 7 are supplementary. Okay? And they say by substitution. So just to show you guys why it's substitution real quick. In statement number 3, we say that 4 and 6 are supplementary. Right? However, if 1 is congruent to 4, wherever I see 4, I can replace it with a 1. We see angle 6 here. However, if 7 and 6 are congruent, wherever I see 6, I can replace with 7. So what I did there was substitution. Number 11, find the measure of angle T. The diagram is not drawn to scale. Every time they tell you the diagram is not drawn to scale, they tell you that because they don't want you to assume anything based on the way the picture looks. Right? Now, angle T is right here. Okay, so we know that we're not done until we have a value to put there. They do give us some information, so let's see what they do give us. I'm looking at this line and this line. Okay, notice that they both have an arrowhead, which means that they're parallel. Okay, when they're parallel, that tells me all kinds of special relationships happen. Okay, now if you look up top, we have T. You also can tell, hey, here is a straight angle. A straight angle measures 180. So if I take this angle plus T plus V, I should get 180 degrees. If I can find this angle over here, an angle V, I can add them, then subtract from 180 to find T. So this one doesn't have a name yet. I'll call it angle R, just to give it a name to make it a little bit easier to work with. Okay. Now, if we're looking at this line right here, this purple one, and then this one right here. Notice I just took two lines that intersected, and they formed an X. Opposite to each other are 58 and V. I gave them each one arc because those two are vertical angles, and vertical angles are congruent. So angle V is going to be congruent to 58 degrees because they're vertical angles. Okay, so they're congruent, that means they're exactly the same. So wherever I see V, I can go ahead and put 58 degrees. Okay, notice I'm a little bit closer to finding T. Now, Next thing we're going to take a look at here. We have this line right here, and then we have this line right here, okay? And we're also going to be looking at this line right here, okay? This area in the middle would be known as our interior, which means the area on the top and on the bottom would be known as exterior. If you look at angle R and you look at angle 36, this one right here and this one right here, they're both on the exterior and they're on opposite sides. R is on the upper left, 36 is on the bottom right, okay? Those are what we call alternate exterior angles. So they're going to be congruent to each other because of that. So angle R is going to be congruent to 36 degrees because they're alternate exterior angles. Which means they're congruent. Okay? So if that bottom one is 36, R must also be 36 degrees. Now notice we found R and we found V, but what we haven't found yet is T. We know that R plus T plus V equals 180 degrees. Right? So we know that angle R plus angle T plus angle V should equal 180. We now know angle R is 36 degrees. We also know that angle V is 58 degrees. And that they all add up to 180. What we don't know yet is angle T, okay, which we want to solve for. So we're going to take 36 plus 58, which is going to give us 94. So angle T plus 94 is equal to 180. And then the last step, if we want to solve for T, is to subtract both sides by 94, or to take 180, take away 94. So we're going to find out that the measure of angle T is going to equal, let's do that. We can't do 0 minus 4, so take one from the neighbor. That becomes a 7. 0 becomes a 10. 10 minus 4 gives us 6. We can add to 7 minus 9, so we take one from the neighbor. That becomes a 0. That becomes 17. That's going to give us 86. So the measure of angle T is going to be 86 degrees. Number 12. Given that E is the midpoint at DF, find line segment EF. Right? First piece of information they give us is given that E is a midpoint of DF. So here's D. Here's F. They're telling us that E is the midpoint. The midpoint means the halfway mark, which means that the two line segments created, the two smaller ones, must be congruent. So DE is congruent to EF. And then the last set of directions is find EF. Okay, so right now, EF is obviously this one right here, from E to F. They want to find the length of it. Right? On top of it, it just says 2x plus 41. You can't tell me how long that is because it has a variable in it. If I need to solve for a variable first, that means I need to set up an equation. So I need to find two things that are equal to each other. Notice that DE and EF both have one tick mark because, again, E is the midpoint, so E is a halfway point. So the line segment DE is going to be congruent to EF. And what it means to be congruent is the same, so they're the same length. Right? I'm going to replace DE. I'm going to substitute the value, the expression 5x plus 17 equals, and then for EF, I'm going to plug in, I'm going to substitute the value, the expression 2x plus 41. Okay. So first thing we got to do is go ahead and solve this equation for x. Distributive property is the first step, but it's not needed because there's no parentheses. Step 2 is to combine like terms. If you cover up the left side, on the right, you cannot combine 2x and 41 because 2x has a variable, 41 is just a constant. If you cover up the right and you look at the left, 5x and 17 also cannot be combined because one has a variable, the other one's a constant. So we move on to step 3, which is to add or subtract. We want variables on one side, constants on the opposite. I always move variables first, and I like to get them where they're bigger in order to avoid negatives. Now, 5x on the left is obviously bigger, so I need to move the 2x to the left. Currently, it's positive, so I'm going to have to subtract 2x from both sides. Okay. On my left, 5x minus 2x is 3x. Then I'm going to go ahead and bring down the plus 17 equals 2x minus 2x will cancel. And I'm going to go ahead and bring down the positive 41. Okay. And what I accomplished in that one step was getting all my variables to the left. Now I need to get constants to the right. 41 is where it needs to be. A positive 7 needs to join it. So in order to undo plus 17, I'm going to subtract 17 from both sides. Okay. On my left, 17 minus 17 will cancel. I can bring down 3x equals. And then 41 minus 17, I can't do 1 minus 7, so borrow from the neighbor. 4 becomes 3, the 1 becomes 11. 11 minus 7 is going to give me 4, and then 3 minus 1 will give me 2. Variables are on one side, constants are on the opposite. Last step is to divide or multiply. This is 3 times x, so to undo the multiplication by 3, I'm going to divide both sides by 3. 3 divided by 3 is 1, so we bring down the x, and on the right, 24 divided by 3 is going to give us 8. Okay. Now, that's nice. We did solve the variable, but we still need to find EF. So now we need to go ahead and plug it back into the line segment EF. So the length of EF was 2x plus 41. But now that I know x is equal to 8, I'm going to go ahead and plug that in. I'm going to substitute it in. So we have EF is equal to 2 parentheses 8 plus 41. All right, so we have EF. 2 times 8 will give us 16. 16 plus 41. So we have EF equals, that's going to be 57. Okay. So we needed to first set up an equation. Then we needed to solve that equation for the variable. And then once we solve that variable, we need to plug it in to find the actual length of EF. So that'll be our final answer.